Good day, math learners. Now let's talk about point and interval estimation. So in the previous discussions, it had been established that in reality, it is almost impossible to work on the entire population. Keep in mind that a sufficient number of members of a representative subset of the population we call as random samples should be utilized to approximate population parameters. The process of getting samples from the population to get an approximation of the population parameters is referred to as inferential statistics. Now, the inferences that we'll make out of the sample for the population is subject for uncertainty. That means not 100% accurate. In simpler words, there is a chance or likelihood of getting wrong inference about the population, and we will try to measure this likelihood so we can minimize it. Point estimate is a single value taken from the random sample of the population to approximate the population parameter. The process of finding the point estimate is called point estimation. The sample mean is the point estimate of the population mean, and the sample variance is the point estimate of the population variance. Point estimates should not be necessarily equal to the population parameter. However, point estimates should be as close as possible to the population parameter. Outliers are data that vary greatly from the majority of the data set. Outliers can greatly affect the sample mean. Now, while a point estimate is a numerical value and it identifies a location or a position in the distribution of possible values, an interval estimate is the range of values where most likely the true value will fall. Interval estimates are also called confidence intervals. So confidence interval is the range of values within which the population mean is most likely to be located. In approximating the population mean using confidence interval, confidence levels are used. Confidence level refers to the probability that the confidence interval contains the population parameter. The confidence levels of 90%, 95%, and 99% are the most commonly used confidence levels in researches. So in computing for confidence level, level of significance is also needed. So level of significance is denoted by alpha, is the probability that the confidence interval does not contain the population parameter. So the level of significance can be arbitrarily chosen, but 0.1, 0.05, and 0.01 are the most commonly used values of level of significance. So let's have here. We have the three most commonly used confidence levels. Those are 90%, 95%, and the 99%. So if the confidence level is 90%, then the level of significance is just 100% minus 90%. So that is 10% or 0.1. Okay? Now, if the confidence level is 95%, that is just equal to 100% minus 95%. So that is 5% or 0.05. And if the confidence level is 99%, then the level of significance will be 1%, or in decimal, that will be 0.01. Okay, so these are the three confidence levels that are most likely used in researches. And here are their corresponding level of significance. So the critical value is the value that indicates the point beyond which lies the rejection region. So the rejection region does not contain the true population parameter. Now let's have interval estimate to the population mean with known variance. So when the population variance is known and n is greater than or equal to 30, the formula for the interval estimate is this one. Okay? Where x bar is the mean of the random sample size n is a sample size, sigma is a population standard deviation, and z sub alpha over 2 is the z value at 1 minus alpha over 2 confidence level. And we have here a quite complicated formula for the interval estimate, right? So let's simplify this one. So to simplify, the confidence interval can be written as the population mean is greater than the difference of the sample mean and the margin of error, but is less than the sum of the sample mean and the margin of error, wherein x bar is the sample mean, e is the margin of error computed as z sub alpha over 2 times population standard deviation over square root of the sample size. X bar minus E is the lower confidence limit, and X bar plus E is the upper confidence limit. The confidence limits are the values at the end of the confidence interval. So these are the lower confidence limits and the upper confidence limits. Okay, now let's have an example. Let's have this one, example 1. The mean score of a randomly selected 49 grade 11 students who took a test is 78. So the population standard deviation is 0.4. Find the 95% confidence interval for the mean of the entire grade 11 students. So let's identify our given. Okay, the mean score of randomly selected 49 grade 11 students who took the test is 78. So 78 is our sample mean. Population standard deviation is 0.4. That's very obvious from the problem. And our sample size is 49. Our confidence level is 95%. So the level of significance is 0.05. Right? Okay. So step 1, let's find z sub alpha over 2. So since alpha here, level of significance is 0.5, so alpha over 2 is equal to 0.5 over 2, and that is 0.025. Finding the corresponding z-score of 0.025, we subtract 0.25 from 0.5. So that is 0.5 minus 0.025, that's equal to 0.4750. Now, what do we do next? We look at the z table. So you get your z tables and find the area 0.4750. Find this area from the z table. So here we have our z table, finding the area of 0.4750. Where is it? 0.4750. It's here. So the area is here. So this is the area that we're looking for, 0.4750. So that's 1.9 and 0.6. So here we'll write the z value of alpha over 2 is equal to 1.96. Okay? Now let's go back. Alright, so we have utilized the z table and the corresponding z value of alpha over 2 is 1.96. So proceed now to step 2. Let's find the margin of error. So in finding the margin of error, okay, let's just substitute. So we have 1.96 times, okay, our population standard deviation is 0.4 over the square root of 49. So it will give us 0.112. Step 3, substitute the computed values in our interval formula. So we have the population mean is greater than sample mean minus the margin of error, but is greater than the sample mean plus the margin of error. So our margin of error here is 0.112 and our sample mean is 78. So the population mean is between 78 minus 0.112, so that's 77.888, and 78 plus 0.112, that's equal to 78.112. So the population mean, okay, let's round off 2 decimal places only for our upper and lower limits. So the population mean is greater than 77.89 but is less than 78.11. So the lower confidence limit is 77.89 and the upper confidence limit is 78.11. So this means that at 95% confidence level, the population mean is between 77.89 and 78.11 when the sample size or when the sample mean is 78. Okay? Now let's have example 2. So the mean score of the randomly selected 49 grade 11 students who took the test is still 78. The population standard deviation is 0.4. Find the 99% confidence interval for the mean of the entire grade 11 students. So this time, most of our given are just similar with the previous example, but our confidence interval is now 99. Our confidence level is now 99%. So confidence level is 99%, so the level of significance will be 0.01. Step 1. Let's find z sub alpha over 2, and since our alpha is 0.01, then alpha over 2 is 0.01 over 2, and that's 0.005. So subtracting 0.005 from 0.5, that will be equal to 0.4950. So from here, we'll now use our z table to find the corresponding z-score of 0.4950. And we are back to our z-table. So finding 0.4950, the area 0.4950, okay, so here we have 0.4949 and 0.4951. Okay, we don't have the exact for 0.4950, but we have 0.4949 and 0.4951. So we can use these two. So what we have here, it's with, okay, so we have 2.5. So 2.5, and then, okay, 2.57 and 2.58. Okay, so going back, since the area 0.4950 on the z table is between 0.4949 and 0.4951, so that will be 2.57 plus 2.58 divided by 2, so we'll have 2.575. So the z-score of alpha over 2 is equal to 2.575. Now we can proceed to finding the margin of error. So the margin of error now is equal to 2.575 times 0.4 over square root of 49. So it will give us approximately 0.147. Step 3, substitute the computed values in our interval. So we have the population mean is greater than 78 minus 0.147, but is less than 78 plus 0.147. So rounding off, that will be the population mean is between 77.85 and 78.15. So the lower confidence limit of our interval here at 99% confidence level is 77.85, and the upper confidence limit is 78.50. So this means that at 99% confidence level, the population mean is between 77.85 and 78.15 when the sample size is 78.